Our next panelist is Eugenio Gómez Reyes. He has a BA in Oceanology from the University of Baja California. He has a master's degree for coastal management and a PhD in oceanography coastline from the Sea Sciences from the School of New York. His areas of research is circulation, dispersion, and transportation in estuarine and coastline lagoons, quality of water, and the modeling of coastal lagoons. He has published books on pollution of water, hydrology, and water quality. Has obtained the following recognitions: honor mention from the School of Marine Sciences from his university, and received the award of Kenneth B. Stout from his master's thesis in a complex solution of the marine environment. With you, Eugenio Gómez, PhD. Good afternoon to you all. Thank you very much for the invitation extended to me, and we are here to share a project, an experiment we have carried out, and for which we have required statistical and geographic information. And we will be dealing with it from the user's point of view. What is it we use to get the information, how we process it, and what we derive from it. This project of the basin of the Valley of Mexico is a representative example of the type of information that we can use for all the different basins. We will start out, and the title here differs from the one in the program. It's not that we will not be looking at the model, but the emphasis will be on the use of information used for these types of models. What we will see in the first place is the present status of the water resource in the basin of the Valley of Mexico, and the need to carry out assessments and measurements and obtain the information they needed, and the sources of information, as well as the visualization of these results and the different scenarios we produce with this information. Maybe one of the summaries that can better describe the condition of the water resource in the basin of the Valley of Mexico is this image of Conagua that appeared at the beginning of this sexennium, by which we detail information of all the inflow and outflows and the uses of water. We would have to add, to complete the information, as the re-entry of water, but it essentially covers all the aspects. This information is, as stated a while ago, this is the statistics. So the way we process it leads us to shaping up our knowledge basis. And a brief applying mathematics or analyzing this information, we see an interesting problem. Interesting for the challenges it produced. Of course, it's not desirable, but it is there. For instance, in my last point, if we were to add all these flows, inflows and outflows, we have a change of volume in the basin, and we call this the storage. And the storage we have here, fortunately, is positive, but it's approximately 3 cubic meters per second. If we were to divide this in 150 liters per inhabitant per day, we get approximately 1,800,000 people that can satisfy their demand for water. Almost the population of the delegation of Iztapalapa. And for the basin of Mexico, this storing is almost zero. And these storages are in 3 dams, Guadalupe, Madin, and the Concepcion. Those who live, of us who live in this area, know that in these dams, the sewage waters are discharged. So whatever is stored is polluted. So we cannot use it right off. So this causes enormous problems. Now, let us suppose that even though the growth of the population be kept in the federal district, which is practically zero, but in the conurbated areas, like in Tecámac, it's 4 to 7%. And we still have demographic growth, but if there weren't any, we continue to have an economic development. And at what rate do we want to grow? So at what rate we want to grow is determined by the amount of water we have. Obviously, we don't have it. And what are we going to do? Are we going to benefit the economic development, the population development? It depends on who shouts more, who demands more, and who receives more water, since we are competing for its use. So we have suffered the crises that have not been generalized, but within the measure that time advances, we are facing a terrible situation as to whom we are going to favor. This requires immediate action. If we continue with the second item, all the recharge of the aquifer and subtract the use and the extraction wells, although we still have some waterheads, we see that there is a deficit of 30 cubic meters per second, an enormous excess exploitation, and this explains all the problems of the cracks, the leaks in the drainage systems and in the distribution networks. It is an enormous problem, and it needs amounts we cannot obtain. But if we observe the first point, is something that we have not analyzed in depth, but we have a disbalance in our basis, what we bring in from the Lerma Cutzamala and what we export to the Tula Basin. So we have the 30 meters per second cubic meters we need to balance our aquifer. So we have to think along those lines, especially in the management of water. Apparently, we have the alternative to balance the deficit. And right now, with the water policy, we see that we have no strike, no balance. All the rainfall is used, and we are faced by a paradox. We don't have water in the water faucet, but we are being flooded. And if we continue analyzing, we might reach a point stating that the crisis is not due to water crisis, but rather to the management. We have the resource, but we don't use it appropriately. So what are we doing? In the WAM, we have had the opportunity of integrating a multidisciplinary team to carry out analysis and studies, assess alternatives, and determine what we are to do. And we have been able to integrate two important aspects. The water aspect.
Where is it we have shaped the water models and to measure the water? What is it we do with the water? Here we have the feasibility of the water feasibility and the options we may have. In addition, we have been able to analyze the economic sectors in order to produce and present options based on a multi-sector economic model. What I will present from now on will be based on what we need to operate this water system and the solutions we have drawn from it. Tomorrow with Dr. Rodriguez Tapia, we have scheduled the multi-sector model. We will delve into that and we will combine this phase of the project. Hence, the structure that encompasses the numerical model is the statistic and geographic information that is needed for the water model as well as for the multi-sector model. And lastly, viewing the results and outcomes. And as additional information that is required for the models, we have classified all this information. This information has been requested as a user. It's no hypothetical information we should use for the water model. We need to have a basic map of the basin of Mexico City, of the Valley of Mexico, and the water infrastructure to get to know the infrastructure and the water processes and the use of water, as well as the returns on water. And the economic model, we need the water accountings that were referred to this morning, the flows that have been listed here for the social accountability matrix for that information. Very well. Now, in regard to the basic map, we need a great amount of information that's listed here. We need the level curves, because we start from this level curve in this model to come up with a landmark based on the maximum altitudes and then the slopes in a digitalized manner, and then to add the information from INEGI and CONAGUA about the basins and sub-basins. We also need the political information from the states and the municipalities, because when we produce the water management information, we exercise this information based on not on the water network and the basins and sub-basins, but based on the political divisions, the municipalities, the delegations. So we need all the information on the management of the basin and add it up to these entities, and also the urban design. Where are we located? The population, of course, how many inhabitants we have, how much use or how much water do we need, and where they are located. We also need the hydrography. Where are the rivers? Because unlike many other basins, you don't see it here, but there are close to 46 rivers. And you ask me, well, where are they? They have been put into pipes. You have gone over them in the highway, but we have a great amount of rivers and the and water networks. Because of rainfall, we also need information of the aquifers, how far they go, in order to draw a balance. We also need to know the surface harvestings, the streams, the water sources, the extraction and observation wells, and the basin of the Valley of Mexico. I have not checked on this datum, but there are close to 300 to 400 absorption wells in the Valley of Mexico. And that's important. Well, from the 3,000 extraction wells, that's quite a breach, but we're getting there in land information, soil information. And look at the infiltration, the vegetation coverage, the recharge areas, and the weather stations and the hydrometric stations. And so this information was used in order to design the information required by the water model. This is only to create our basic map. And we also need all the information of the water infrastructure, the location, the volumes of the storage tanks, the water treatment plants, the drinking water plants, the residual water plants. Where do they arrive? Where do they stem from? How much do they have? The drinking water networks. How many spillages? And the sewages, the sewage networks, and the distribution of treated water. and especially the irrigation districts, only 2, very small if we compare them with the other basins, but also very important, such as the urderales, the irrigation units. All this information gives us an idea of the infrastructure we have. And furthermore, we need water information, hydrological information to calculate the water volumes stemming from the hydrological processes, evapotranspiration, runoffs, rainfall, operation of the vases. And all the possible uses of the water that have been registered in the public registry of the rights of water. And that is mentioned here. We added them here for domestic use, agricultural use, and this is where we added all the elements. And we also require the knowledge on the economic expenses, the recycling of water, the reuse of the treated waters. So far, this is such a humongous amount of information, and this is where we need to carry out these exercises. And I have to tell you that we need this information on the returns of water, and in the inventory of the residual water discharges, we can know about the industrial, commercial, and service water discharges. And we need to know what is the domestic return of water, to know what the agricultural return is. And in regard to the water model, and I will briefly mention the information that will be enlarged tomorrow, the information of the economic sector. And we need the consumptions, the production, and the economic agency. And we also need this information in yellow. That's so important that INEGI does not produce it yet. We need to produce it. We could have been able to produce it. And all of this to analyze the effects in the economic sector about some possible options to be submitted in the case of water. Now, what did we do in this regard? Let me go back 2 slides. There. The database. We consulted with INEGI that did not have all the information. Now, with the debates this morning, they are coming up with a system in the surface water system, but specifically in regard to the hydrological processes, rain, runoff, and infiltration. And in everything that has to do with the treatment, water treatment systems, that was not available, but we use the information from Conagua, Sedubi, Semarnat, and the local Senapred, Canacintra, Conavio, Sedena, INIFAB, with the networks, the weather networks that provided good information, the Mexican Institute for the Water Technology, and UNAM in the PUMA environmental program. And to review all this information base is an intense endeavor. So what we did is that we designed and we applied a system that we call the system for water information. It doesn't look like the national system at all, but it comes in quite an adequate manner. It searches in all these databases, and automatically, it's like a Google system. You just click on search. I want to look for this and this. For instance, water streams and water sources, and it searches nationally, locally, and internationally, searches the databases, and when it finds, for instance, the flow of water in the rivers, and this will take us to the database of bandas, for instance. but maybe there's another institution that has this information that can provide it, and the system shows it. And based on that, we created our database. And from there, what do we use it for? Well, we process and calculate the volumes, or calculate the management of water, the operation system. These are the graphs. And briefly, I will just show them briefly to look at the capacity. And what I've seen here, and what we do with the information, is that we use it and we send it to an geographical information system that is useful. But when we have to make calculations on this information system, it does not allow us in full capacity to resolve differential equations, to calculate sophisticated algorithms. So what we did is that we created a geographic information system, exactly how a system works with the different layers and everything you know about the CHE files. And this doesn't work in CHE files. It works in ASCII files, so that it's more universal. And this is not a public system, but they have Octal already for public dissemination, and we're transferring it to a public dominion so that we don't have to purchase the software to use it.
With all the topographic information, we define the basins, the sub-basins, and also applying the same techniques. We obtained approximately 108 micro basins, and here we point at the different stations, the ceilometric stations. When I wanted to cover this quickly, but it won't work. This is an image of all the municipalities of the Basin of Mexico. All the information I have submitted is showing the urban sprawl with the irrigation units. Climate stations, the isoyets, all the processes that have to be generated for the runoffs of each area. This is information of the outflow from the Basin of Mexico. What are the volumes of water that the 4 outflows have towards Tula? All the information of the uses of water, how this is classified under industrial, and all the different uses. We have information at the level of sub-specific basin. This is an example of the basin of the Amecameca and the Compañía River, and an estimate of some flows to estimate the storage dams, or know where flows are coming from and what quantity there is. I don't know which one this is. Let's see. Right, and this is an example. I don't know if you're able to see it, but this is a table of results in regard to the hydraulic operation. This essentially is the information. You are able to see it. Yes, please center this. All right. Here we are indicating all the flows we have subdivided into the supply and the total use. And we have here, you see that all the water supply, 92,032 cubic meters per second, everything is used up and the different uses. And we also have the amount that go to the drainage, the rainfall drainage, and the amount of sanitation drainage. And please check the important amount of loss, almost 16 cubic meters per second are from the Cuxamala system. We extract 19 from what we bring from the Cuxamala-Lerma system is equivalent to what we waste in leaks. And this is an important task for those that design the works of the Lerma system, have to invest in the repair of leaks, because we are referring to an enormous equivalence as to losses. And this in regard to management, different balances. One was already mentioned, transvasing, atmospheric balance, the amount of rainfall we still have vis-a-vis transpiration or loss through evaporation. And the last ones we have some of the simulations we carried out to provide alternate solutions, which is included in the book called Rethinking the Basin, another alternative for the management of water, and the sub-basin of Amecameca and the Compañía rivers. We based ourselves on this information for the hydraulic plan and my conclusions since yesterday. And this coincides with everything we have been talking about during this morning, and maybe they are highly synthesized, but we must concentrate the information. As you realized, we use many sources, and we have to make each source consistent with the other. We didn't know whether to carry out the model or produce the database. This effort has to be coupled. If we had information that is highly concentrated and of good quality, we might have solved problems sooner, or we have known better how to solve the problem of water. And there's an important element. All the public universities have stated that this is not demanded by society, but all the projects in the universities, the seat, and those that finance the projects should demand the delivery of the database, and not just any database, but well purified in a Mexican format whereby we could have immediate access to it. This was stated here clearly here. The best way to get the value of the data is to give them away, and this does not happen. We have the information, and I know somebody, and he has the information. I can exchange it, but we don't have that culture, and it is important. This type of fora help us to provide an initiative. This is all I had to say. Thank you very much. Thank you, Dr. Gómez. While we receive the questions for